Have you ever wondered where everything came from? Like not just Earth or the stars, but space, time, and reality itself? What if I told you the entire universe was once smaller than a grain of sand? In today's video, we're diving deep into the ultimate origin story, the Big Bang. How did it happen? What came before it? And are we still feeling its effects today? Grab your curiosity because this journey will blow your mind. Ready to travel back 13.8 billion years? Let's explore the beginning of everything together. What was the Big Bang? Hey, have you ever looked up at the night sky and wondered, how did all this even begin? I mean, everything. The stars, the galaxies, the very space between them. It's mind-blowing to think that the entire universe once fit into something smaller than a pinhead. That's not just poetic, it's science. Scientists call it a singularity. No stars, no planets, no time, no space. Just infinite density and temperature packed into one unimaginable point. And then boom, about 13.8 billion years ago, the universe began. But here's the twist. The Big Bang wasn't an explosion in space. It was the sudden expansion of space itself. Space stretched, time ticked for the first time, and matter began to form. From nothing came everything. There wasn't some big kaboom with fireworks flying into empty darkness, because there was no outside to begin with. The Big Bang created space, time, energy, and all the rules that govern our reality today. It's like reality booted itself up from zero. And here's the real kicker. You, me, the device you're watching this on, we're all made of the same ancient energy that burst forth from that original moment. So next time someone asks where you're from, you can say, the Big Bang. It's not just science fiction, it's your origin story. The first moments. Alright, let's zoom in on those first few mind-melting moments after the Big Bang. And by moments, I mean we're talking less than a trillionth of a second. Imagine the universe going from microscopic to cosmic in the blink of an eye. That's called cosmic inflation. It's not just fast, it's ridiculously fast. We're talking faster than light expansion. In this phase, space itself stretched so rapidly that tiny quantum fluctuations, tiny ripples in the energy fabric, were stretched into the seeds of galaxies. No joke, those little wiggles eventually became us. During this period, the fundamental forces of nature began to separate: gravity, electromagnetism, and the nuclear forces. Think of it like the universe untangling its own rulebook while it was still being written. And even though it was blazingly hot, energy condensed into particles, the first building blocks of matter. We're talking quarks and electrons, not yet atoms, but the very idea of matter. It's wild to think that everything we see today, galaxies, black holes, pizza, memes, started from this chaotic, intense moment. Inflation not only made the universe big enough to evolve, but also smooth enough to become the calm cosmos we observe now. And the best part? We can still see the echoes of that inflation today. The afterglow is still out there, frozen in time, whispering the universe's birth story across the sky. Big Bang nucleosynthesis. So now that the universe has gone from a quantum seed to an expanding, fiery mess, what's next? It cools down just enough to start cooking. And I mean literally, cooking elements. Around 3 minutes after the Big Bang, yeah, just 3, the temperature drops to about 1 billion degrees. That's when something magical happens. Nucleosynthesis. Protons and neutrons start teaming up, fusing together to form the very first atomic nuclei. Not full atoms just yet, but the cores. The recipe was simple, but it changed everything. Take a bunch of protons, stir in some neutrons, apply insane heat, and you get the universe's first ingredients. Hydrogen, helium, and a sprinkle of lithium. That's it. No gold, no oxygen, no iron. Just the basics. But these basic ingredients were like cosmic Lego bricks. They were the raw materials from which stars, galaxies, and life itself would one day form. Think about it. Every drop of water, every breath you take, every cell in your body is built on the foundation laid during those first few minutes of creation. And what's even cooler, the predicted ratios of these elements match exactly what we see in space today. That's how scientists know this theory is on the right track. The Big Bang wasn't just an origin story, it was the universe's first chemistry class. And you're the long-term result of its wild experiment. The universe's afterglow. Let's jump ahead to a universe that's about 380,000 years old. By cosmic standards, it's still just a baby, but something extraordinary is about to happen. Until now, the universe has been a swirling, chaotic plasma soup, so hot that light couldn't travel freely. Photons kept crashing into free electrons like bumper cars in a demolition derby. But suddenly, The universe cools just enough for electrons and nuclei to finally bond and form neutral atoms. And boom, light breaks free for the first time. That ancient light is still traveling across the cosmos today, and we call it the cosmic microwave background, or CMB. It's like the baby picture of the universe, faint, stretched-out radiation that tells us what the universe looked like when it was just a few 100,000 years old. And guess what? Scientists have captured it. It's not just theory, they've measured it with satellites like COBE, WMAP, and Planck. What they found was astonishing, a nearly perfect glow spread across the entire sky with tiny variations that hinted at future galaxies. So when you stare up at the night sky, just know you're bathing in ancient light. It's the literal afterglow of creation. The universe left us a message in its own light, and it's been whispering its story for almost 14 billion years. Kinda romantic, right? Evidence supporting the Big Bang theory. Okay, so all this Big Bang stuff sounds cool and cosmic, but let's be real. How do we actually know any of this happened? I mean, it's not like we were there with a camera 13.8 billion years ago, right? Well, this is where science flexes hard. The Big Bang theory isn't just a wild guess. It's backed by solid, observable evidence. First, up galactic redshift. When we look at distant galaxies, their light is stretched, shifted toward the red end of the spectrum. Why? Because space itself is expanding, pushing galaxies apart. It's like raisins moving apart in rising dough. Second, remember the cosmic microwave background we just talked about, that faint glow? It's exactly what you'd expect if the universe started as a hot, dense fireball. Third, we have the elemental recipe. The universe's mix of hydrogen, helium, and lithium perfectly matches the predictions made by Big Bang nucleosynthesis. It's not just a lucky guess, it's precise. Scientists didn't just make this stuff up after seeing the results. They predicted it first, and the results matched. That's what makes it so compelling. The universe isn't keeping secrets. It's actually leaving breadcrumbs all over the place. And we've been smart and curious enough to follow them. That's why, today, the Big Bang theory is the most widely accepted explanation for the universe's origin. It's not just a theory, it's evidence-based storytelling written in starlight. Ongoing mysteries and the role of dark components. Now, before we all pat ourselves on the back, let's admit something. We don't have all the answers. Not even close. In fact, 95% of the universe is still a total mystery to us. Yeah, you heard that right. Everything we can see, stars, planets, people, pizza, that's just 5%. The rest, it's made up of dark matter and dark energy. Sounds like something out of Star Wars, but it's real. Dark matter doesn't emit light, doesn't absorb it, and we can't see it, but we can see its effects. It's like a ghost holding galaxies together, adding gravity where there shouldn't be enough. And then there's dark energy, the invisible force pushing the universe to expand faster and faster. Imagine driving a car that accelerates on its own and you can't find the gas pedal. That's our universe right now. These two dark components dominate the cosmos, but we barely understand them. It's humbling, isn't it? Even after decades of research, we're still staring into the dark, asking questions. And maybe that's the best part. The Big Bang doesn't just give us answers, it gives us better questions. It reminds us that curiosity is infinite, just like the universe. Expansion continues. So now we know how the universe began, but here's the final question. How will it end? Will the universe go out with a bang, a whimper, or something we can't even imagine yet? Let's talk about the possibilities. First, if dark energy keeps pushing everything apart, galaxies will drift so far away from each other that the night sky will go dark. Literally. Stars will die out, matter will decay, and we'll be left with a cold, empty void. Scientists call this the Big Freeze or heat death. Not exactly cheerful, right? Another theory? The Big Rip, where expansion gets so intense that it tears galaxies, stars, planets, and even atoms apart, like the universe is being pulled apart at the seams. Then there's the Big Crunch, a sort of cosmic rewind. If gravity somehow wins over dark energy, the universe could collapse back into a singularity. Boom, back to square one. And hey, there's even the bounce theory, where the universe ends and begins in an endless cycle of bangs and crunches. We don't have the final answer yet, but we're watching the clues. Telescopes, satellites, simulations, they're all trying to read the universe's endgame. One thing's for sure, we're living in a cosmic story still being written, and isn't it wild that we're here right now, on this tiny blue dot, wondering how it all began, and how it might end? And just like that, we've traveled from the tiniest singularity to the vast cosmos we call home. The Big Bang isn't just science, It's our origin story, written in stars and stardust. If this blew your mind even a little, imagine what else the universe is hiding. Don't forget to hit that like button, subscribe, and ring the bell so you never miss a cosmic journey. Got questions? Drop them in the comments. I love hearing your thoughts. This is Space Facts, and the universe is just getting started. Until next time, keep looking up.